Welcome to Shift, a college admissions, SAT, and CLT podcast for a changing world. I'm Tyler, the founder of Achievable, and we have affordable ACT and CLT courses that include everything you need to ace your exam. A full textbook, tons of review questions backed by our memory-enhancing algorithm, videos on key topics, a built-in study planner, and full-length practice exams. You can get a free trial at achievable.me, and if you like it, use the code podcast to get 10% off at checkout. Now, let's get started. Today, we've got Clay Daniel from Clayborne Education here with us. Clay, I'd love if you could introduce yourself again and your company.
Yeah, I'd be delighted. Thanks, Tyler. My name's Clay. My company is Clayborne Education, as Tyler mentioned. And we have been for, about 16 years working one-to-one, primarily one-to-one with students in the test prep world, helping them kind of clear the hurdles and the boundaries that admissions tests for both college and graduate school can often represent. But with regard to the CLT in particular, it's a newer test on the block, but one that I have intimate familiarity with, and a particular enthusiasm for, having worked at schools as part of my professional career that offer the test to their students. So I'm really excited to talk about what's unique about the CLT and try some hard problems.
Yeah, exactly. And for the listeners, we did do an episode previously where we talked through some examples like we're going to do today over audio. There is going to be a question set that you can follow along. It's going to be, I'll put the link in the description, but the link is also bit.ly/CLT Quant, QUANT, hard questions. And so, check that out when you get a chance, or you can look for the link in the description if you want to follow along. Otherwise, we're going to do our best to describe these. But before we get to that, maybe just a little bit about what makes the CLT Quant different would be interesting, right? Because, I think everybody's kind of familiar with like the SAT and the ACT Quant, but not so much with this one.
It is a little bit different, and that is a function of the kind of student that is likely to take the CLT. The C in CLT stands for classic, and there's a tie there to what's known as the classical tradition or classical school movement in particular, which is something that has sprung up in the last few decades. And one of the things that classical schools tend to value highly is the use of logic. There's an old Roman idea called the trivium, grammar, logic, and rhetoric, that was kind of an organizing principle of education. It's the kind of, if you remember learning about somebody like Thomas Jefferson or our early founders of that period and what their education was like, they had Greek and Latin. They probably studied logic. They studied rhetoric. Many of those things are characteristic of the classical tradition. So when it comes to the math section, you'll see that emphasis on logic. In fact, one of the three problems that we are going to talk about today feels more like a logic puzzle than a math problem, in some ways at least. There's a math component to it that we'll talk about, but among other smaller differences, I think that's one of the biggest things that makes CLT Quant most unique from the math sections on the ACT and SAT.
Yeah. And I mean, it's one of the things I really like about the CLT Quant, because it feels like there's quite a bit of the ACT and SAT math that is more or less testing whether you memorize the formulas you need to solve this.
Right.
And so I like that we're getting away from that.
Me too.
Yeah. I also I don't know. I've always begrudged memorization, even though I know it's important. Maybe that's why we started this company, right? It makes you do it. But great. So let's talk through these. And I mean, I think one of the things to note, for the people listening along is that like we have a PDF in front of us, and we're going to share it. But if you don't, I think just try to envision it in your head to the best of your ability. The other thing too is that these are meant to be very difficult problems. There are, a pretty wide range of difficulties on problems for this test. And that's because, you're trying to suss out kind of where the student falls. And these would be at the top of the difficulty range. So, it's never good to make a direct comparison, but you could say, if you were trying to find an analog, you could say that they were similar to like 1500 level SAT math questions or something like that. And so, yeah, anything else you want to add about that, Clay?
Sure. Well, I would just add that I've kind of coined these in sort of a fanciful way, meaning that I'm calling them difficulty 6 problems, which is technically doesn't exist on the CLT. The math problems go from difficulty 1 to 5. And I basically modeled these after existing difficulty 5 problems at the end of the section and added even a little bit of an extra twist or something that that I think even pushes the student a little bit beyond the highest difficulty. I like to use the analogy with students, if you play baseball or softball, of swinging 2 bats before you go up to hit with one. And the one bat feels really light after you've been warming up with 2 of them on your shoulder. It's kind of the same idea here. So people listening should be aware that, these aren't going to be easy. But by comparison, if you want to practice with the CLT, you may find it more welcoming once you've tried these doozies of questions.
Right. Yeah, exactly. And also, I might get them wrong too.
That's okay.
The other part. So we'll see. I'm going to try my best.
Sure.
But it's going to be fun. So yeah, do you want to start off with the first one?
Let's do. Would you like to go ahead and read it, and then I'll kind of invite you into it part by part?
Yeah, sure. So the prompt is, if A is basically greater or equal to -8, but less than -1, which of the following must be a solution, x, y, to the following system of inequalities? The first is y cubed is less than x plus 8, and the second is y is less than the square root of 4x. Did I get that right? Is that square root of 4x?
Square root of 4x. You got it. Yep.
Okay, great.
All under the radical there. So, yeah, that's how we'd say it. And a question like this often will stop a student in their tracks from the beginning because of the number of variables. They're familiar with x and y, but the original setup and also the answer choices also includes this A. So,
oh, right. I didn't read the answer choices.
Go ahead.
Let me get to that. So the answer choices are, answer choice A, capital A, is, again, it's a set of x, y, and it's -a, 2. Then answer choice B is -a, 10. Answer choice C is A, 2. And answer choice D is A, 0. So, yeah, I mean, it's been a minute since I've done a systems of equations problem, but I almost wonder if you don't need. So the thing about the CLT, and something that I find pretty common with CLT questions, and it might be true here, it might not, is that you don't actually need to solve the math necessarily to solve the question. Instead, you need to figure out what the question is trying to get you to figure out, which is, again, why I kind of like this test. And so the first thing I think is A, negative or positive? I think that is a big direction that I would go in, maybe trying to figure out, but I'm curious what you would recommend.
Yeah, and can you say a little bit more first? You kind of already recognized it by saying that the answers are x, y coordinates. So what is little a? I mean, why do we have another letter in this problem?
I actually don't know the answer.
Okay, sure. Well, when you mentioned it was x, y, in the answer choices, a or negative a is always the x.
Always x.
Right.
Yeah, that's a good point.
So when they introduce another variable, it's not that it's like x, y, and then there's z. There's something completely different. What the a represents is a particular x coordinate, a particular value of x. So for all intents and purposes, we can really just call it the same thing as x. But just like we do in a function sometimes where we plug in one letter, one variable for another, a is in a sense plugged into x in the inequalities. And then maybe we can do something with it. And I think you've already alluded to something really important, and that's that we don't have to completely solve all the way, and probably plugging in the answers is going to be the best approach, which is that's huge because it's very hard to, almost impossible to solve this as a system of inequalities in a kind of textbook way.
Yeah, and it would certainly take too long, right? Like you're trying to get to the end. So yeah, I mean, if you basically say in these systems of equations, or in these answer choices, if you say, it's either negative x comma 2, negative x comma 10, x comma 2, and x comma 0, where x must be between negative 8 and negative 1, but it can be equal to negative 8. That can make it easier to understand, I think. And I mean, it kind of gives you at least some routes to go with the equations above, right? So it's y cubed is less than x plus 8, and then y is less than the square root of 4x. So yeah, I guess from here, would you recommend messing with those two equations at all, right? Because we could try to, do systems of equation-y things. And for instance, like we could square y and then like get rid of that square root. Right. And then, or you could cube y and then they're both y cubed. And then that would be probably, 4x cubed becomes 64x cubed. Is that correct?
It would be the square root of 64x cubed. You're right. If we cube both sides, the square root is still there. But yeah, part of what's fascinating is that we could cube both sides of an inequality without having to worry about any problems with that. But we actually can't square both sides because of the idea where you square a negative and it becomes positive. And there are complications there where we don't know which direction the inequality should be facing. And so the bottom line is the answer to your question is no. Let's not fiddle with the inequalities.
The equations themselves.
Yeah.
Great. Yeah. So then I guess let's then start with the simplest one, which is the top one in a way, right? So you've got basically y cubed is less than x plus 8, right? So x has to be between negative 8 and negative 1 for the sake of being, a menace. We can say that let's make x equal to negative 8. So then that equation becomes y cubed is less than 0.
Right.
Is that even possible? Right? Like, I mean, does answer choice D, a comma 0, is that still ruled out by that at that point? Am I thinking about and solving this correctly? Basically?
Yeah, you're doing the right thing. Yeah, I mean, y squared is less than 0 is impossible because anything squared cannot be negative. But y cubed is less than 0 is still possible. But
right.
Oh, actually, I think I see what you mean. When you ask, is it ruled out? Yes.
Yeah, like for instance, because it's not greater than or equal to. Or so it's not less than or equal to. Yeah.
So we're saying 0 is less than 0 is our result.
Right. Exactly.
Yeah. Very good. So you did rule it out. And notice you only had to try the negative 8 end of the range. You didn't have to try the negative 1 end of the range.
Right. And you could if you wanted to. But I don't think it rules anything out if you do. That was what I was trying, like, for better or for worse, I just noticed that negative 8 and a and x plus 8 lined up, and I felt like that was worth doing first.
Nice. Yeah, that's any little shortcut you can take like that to kind of make it easier on yourself is huge.
Yeah. So what does that tell us, I guess? What did we learn from that? Did we rule out D? Is that what we learned? Or is it more that A is positive or A must be negative? Like, sorry, what did we learn from that, I guess?
Well, I think a couple of things. I think we did rule out D because that's the beauty of having the must in the question. We only need one counterexample, one example where it doesn't work, and you supplied that example. Mm-hmm. But look at the similar choice C. If you did the same thing, but Y was 2, would that work?
Well, also no.
Also no, right. That would be too cute.
So it rules out both of them.
Yeah. And So what you've just done there is actually something we could arrive at from a different route as well, but realizing that the remaining answers have negative a, that a actually has to be negated to make sense. But the second equation gives us a reason for that. Look at that square root of 4x. What kind of number do you want to avoid under a square root?
Under a square root, you want a positive number?
Positive or zero, yes, a non-negative number, but we know that a is a negative number from the initial range. So do you see how it makes sense that negative a is going to work?
Isn't possible.
And positive a will not.
Oh yeah, sorry. So basically, I want to correct what I said because I think it might have been confusing. So if y is less than square root of 4x, and in all of the answer choices, y is greater than 0, then therefore that square root of 4x has to be at greater than 0.
Correct. Yes.
So if you do the square root of a negative number, it gets really weird, or I don't know exactly what happens, but basically it's like, is it imaginary or I forget? It's been so long.
Yes, it's imaginary, right.
So
and
the CLT won't root of a negative number.
Yeah, the students will be happy to know that the CLT will not deal with imaginary numbers. We're staying real, keeping it real.
Keeping it real. So therefore, A would give you a negative number if you put in, because A is negative.
Right.
So it's got to be negative A. So that's another way to get to that same conclusion.
Mm-hmm. Right? Yeah. Great. And at this point, you could take kind of another strategy shortcut informed by what you've already seen, based on the fact that both of the inequalities say y or y cubed is less than something. Do you think we want y to be smaller or larger?
Probably smaller.
Probably smaller.
To make the math a lot easier.
Yeah.
Yeah.
So let's test that.
Square root of 4x, right? So let's just, again, take the example of negative 8, because that's the largest number.
Yep.
And then we have negative 8, and then inside the box of square root of 4x, we put in negative 8. Right?
Very good, yes.
Right. So now it's 4 times 8. 4 times 8 is 32. Square root of 32. Don't actually exactly know what that is, but basically y needs to be less than the square root of 32. Is the square root of 32 less? Is it 2 or 10 that's less than the square root of 32? It's definitely 2.
It's definitely 2.
You can make that conclusion for sure, because the square root of 10 is, if it's 100, the square root of 100, it would be 10.
Right.
So if what's in the square root is less than 100, then you know that it's not going to work.
That's great reasoning, Tyler, and it really helps too, because the CLT, unlike ACT and SAT, does not allow a calculator. So you're not going to be able to just punch in the square root of 32. Estimating and kind of math logic is behind that.
Well, and the square root of 32 wouldn't really help you here anyway. Sure, it would say it's like 4.5 or whatever. Mm-hmm. And so therefore you go, oh, well, 2 is less than that. Right. But you should be able to figure that out anyway.
True. Yeah, that's right. It's between 5 and 6, and those estimating tools can be more helpful on a different problem. But you're exactly right. So it looks like we are getting there, but let's do one more thing. Let's test the square root of 4x inequality with the other extreme. And here's a good strategy to keep in mind. Even though it says a is less than -1, for purposes of our plug-in, we can just go ahead and plug in -1, all while keeping in mind that once we resolve that, it needs to be a little bit less.
Yeah, like 1.01 or whatever.
Right.
Yeah. Right, so okay, if it's -1, then, it's basically, and then you're putting in negative a, so it's square root of 4x, aka square root of -1, aka square root of 4.
Yes.
2.
Which is 2.
Right. So that then it's literally answer choice A, which is -a2, is right there.
It's right there, yeah. If it was exactly -1, we would have 2 is less than 2, which is false. But since it's a tiny bit smaller,
bit more, right? Yeah.
It's universally true that choice A will work. And, we could go back to the first inequality and confirm it there, but I think we've talked about this problem quite a bit. And we also want to emphasize, like, once you know the answer, don't keep testing because the clock is ticking on a test like this.
Yeah. Great. All right, let's move on to question 2. So just so you all know, so just to reiterate question 1, if A is between -8 and -1, it's less than or it's greater than or equal to -8 and then less than -1, then which of the following must be a solution, x, y, of the following system of inequalities? And the system of inequalities is y cubed is less than 8x plus 8, and y is less than square root of 4x. The answer was A, -A, comma 2. Now let's go on to number 2, which is how many integers between 2,000 and 3,000 inclusive meet both of the conditions given in the statement below. Note, digits may repeat. Number 1, every digit is a prime number. And then number 2 is the product of the digits is even. And this is a problem type that I've never seen anywhere else.
Yeah.
Things about the properties of numbers.
Right.
And I think maybe it would be helpful just for the audience for you to basically like explain the opening statement. How many integers between 2,000 and 3,000 inclusive meet these conditions?
Sure. Well, first of all, inclusive means including both ends. 2,000 and 3,000 are candidates here. But this kind of question, a two conditions question, as I call it on the CLT, you're right. It is unique to CLT. Very cool question type. You'll always see it on the test. It will always have a range like this. Normally, the range has lower numbers and it's a smaller range. Part of what makes this problem a difficulty 6 is that it's a huge range with technically 1,001 integers that we could consider, but it must meet both of the conditions below. And so I always tell students, don't necessarily start with the first condition. Pick the condition that to you feels more accessible, where you could kind of either in your mind or on paper list out the examples.
Right. Well, and so the other thing is, digits, right? So what is a digit? So in 2,000, you have 4 digits, the 2, the 0, the 0, and the 0, right?
Good,
and
yes.
So, for instance, let's, like as an example, let's take the number 2,000. Is every digit a prime number? Actually, are zeros prime numbers? I forget that one.
They are not. 0 and 1 are not prime, but 2
so,
is.
2,000. So let's take one that we know every digit is a prime number, which is 2222.
Great.
Right? But this is just to kind of demonstrate for people.
Yep.
So 2,222. Every digit in there are 4 digits is a prime number. Each of the digits is 2. And then the question is the product, which is adding them together, is the product even? So 2 plus 2 plus 2 plus 2 equals 8, right? So the answer to that one.
One correction there,
Tyler.
No,
it's multiplication.
It's multiplication, yeah. Product is multiplication.
Okay, sorry, multiplication. So 2 times 2 times 2 times 2 is, 2 to the 4th. I think it's 32. Is my guess. Maybe I'm off
16.
By 1.
Yeah, you're close.
So it's 16. But yeah, the point, it is even, right? Because it's all 2s. So that's like one example, but now you start to back that out into, okay, but what does this actually mean? So for instance, you can rule out anything that has a 0 in it because the product of is 0 even or odd? I would say
0 is considered even, but it's not prime, so we rule it out based on statement 1.
Yeah, based on statement 1. So you can rule out anything with a 0. You can rule out anything with a 1. Is 1 a prime number?
1 is not prime, right? Which often is confusing, but it's not. Yeah. It's not prime. Yeah.
Then you've got, so then 2 is a prime number, 3 is a prime number, 4 not a prime number, rule it out. 5 is a prime number, 6 not a prime number. Then 7 is a prime number, 8 not a prime number, 9 not a prime number. So you've got like immediately you're crossing off quite a bit of these. And you can basically, I think what I would do is I would probably start from the left and kind of go across. Mm-hmm. So you'd start with the thousands place. Well, it's between 2,000 and 3,000. They all start with a 2 except for 1, which is 3,000.
Yep.
And 3,000 is not going to follow rule number 1 because it has zeros in it, so you can cross it off. So everything starts with a 2. Okay. So now you're really dealing with the rest. You're really dealing with like the rest of the digits. So you've got all the 200s can stay for now. All of the 300s can stay. All of the 500s can stay, and all of the 700s can stay. So you've ruled out another 600 of them.
Great.
Now we're on to the tens digit, right? So again, it's like you do the same thing. And I guess I would almost draw it like a little tree.
Yeah.
And then I think so that would solve basically number 1, and that would probably leave you with some list. So I almost feel like I need scratch paper for this. Are you allowed scratch paper?
You are. Yeah, you do get like 6 sheets.
Let's break out some scratch paper here. This is a fun one. I mean, doing this quickly is definitely challenging.
Yes, that is for sure.
Do I have a pen? I definitely should. Well, in any case, yeah, so that's kind of how I would start thinking about it. Do you feel like that is a good start?
I do. And before we start listing them, there's just one more thing to note, which is sort of just kind of a trick in this question. Think about statement 2 a little further. The product is even. Well, all of these numbers start with 2. We established that, right?
Mm-hmm.
What does that tell you about the product of the digits?
They will all be even?
They will all be even, which means we have a useless statement here. It's redundant. It doesn't matter.
Right. Okay. Yeah, so then you just have to deal with number 1, which is all the digits have to be prime numbers.
Right.
That's some clever question design. That's good.
Glad you like it.
Great. So we got 2, and then that goes to 2, 3, 5, 7. Those are all the hundreds columns. And then each of these also goes 2, 3, 5, 7. And then the last one will also go 2, 3, 5, 7. So this is 4. So this is 4, 4, 4, 4 is 12. And then 12, 12, 12, 12 is 48. No, I didn't do that right. What am I missing here?
I like the way you set it up. We now want to think about this like a combination problem where imagine you have like four students who are sitting in 4 chairs and you want to know how many ways you could arrange the students. Mm-hmm. That's going to be a 4 times 3 times 2 times 1 situation because you can put 4 in the first chair, but then once he or she is there, then there's only 3 and then 2 and then 1.
Oh, right. So there's 1,000th digit. There's 4, and then it's 4, 4, 4.
It is. It's 1, 4, 4, 4. Exactly right.
Okay, so to walk you guys through this because it might be a little hard just with audio.
Yeah.
Basically, if you think about it, think about each of the digits as there's like 4 places. The first digit has to be a 2. That's the only prime number in this set that works. The second digit has to be it's either 200s, 300s, 500s, or 700s. So there are 4 possibilities. And then that repeats for the next 2 digits. So for the tens digit, there's only 2,220s, 2,230s, 2,250s, and 2,270s. And then for the final digit, it does it another time. And so there's only 2,222, 2,223, 2,225, 2,227. So if you simplify that to just like how many options are there at each step, it's basically 1 the first step, 4 at each of the subsequent steps.
Yeah. And should we add or when we have this 1, 4, 4, 4, as you've described well in the steps, should we add or multiply those numbers, do you think?
Multiply.
Yes.
Yeah, because each of them is corresponding to the full set of options for that slot, basically. Right.
Another way to say that is that if you find yourself saying and in your thinking, and means multiply in these situations, or means add. But we're saying we need this digit and this one, etc.
Right. Yeah. So then 4 times 4 times 4, or you could call it 16 times 4 is 64, which is
Very
answer
good.
choice D.
That's great.
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 Yeah, that was a fun one. Once I knew what was going on.
Yeah, it took a lot of kind of setup there. And I want to offer an educated guess approach before we move on. In case you didn't see it that way and you were thinking, okay, I don't want to list out potentially up to 64 numbers with the clock ticking. One way to deal with that is to just take one of the hundreds that Tyler described. Let's say 2200, filling in those last two digits and coming up with all the possibilities. If you brute force that and found that there are 16 possibilities, well, keep in mind that the other hundreds should behave in the same way for reasons you kind of already said. So it should just be 4 times whatever we find out, which at an even more basic guessing level means the answer is probably a multiple of 4. So even if you took another step back and said, I don't even want to write these out, I'm just going to make an educated guess, 2 answers here are multiples of 4, and you've given yourself a 50-50 shot without doing all the work.
Right. Yeah, I mean, problems like these are what I think make the CLT such an interesting test, right? Because it's really logical reasoning based, and the math itself is not like crazy, you're trying to calculate like the slice of a sphere and then put a fence around it, right? Like it's a lot more about like how do you problem solve essentially.
Yeah, it is. The logic of math and the skill of problem solving. You're right.
Yeah, great. Now let's move on to question number 3, and this will be our last one of the day here. Question number 3 is similar to that kind of chair problem, probably.
It is a little bit, yeah.
So, for a school project, a group of 4 students, William, Xavier, Yumeka, and Zion, or for, as I see you have aligned, is W, X, Y, and Z.
Right.
If that's easier for you. Hold a draft of which of each of the students ends up assigning to one of the 4 presidents of Mount Rushmore. Let me say that one more time. So, for the school project, you've got 4 students, W, X, Y, and Z. And they are picking in a draft format who gets which president on Mount Rushmore. And the presidents on Mount Rushmore are Washington, Jefferson, Lincoln, and Theodore Roosevelt. So here's the following is known. Basically, what other conditions are there? The first is that Xavier picks a president whose last name comes alphabetically somewhere before the president Yumeka picks. So essentially, if we were to line up the Mount Rushmore presidents, they would be Jefferson, Lincoln, Theodore Roosevelt, Washington. So Xavier is going to be before Yumeka in that order.
Mm-hmm.
And then Zion does not pick Jefferson. So Zion is not picking the first in the order, if the order matters to Zion. What is the number of distinct possibilities for assigning presidents to students given the limitations above? Interesting. So a lot of times these questions are like, Yumeka picked one of these 2, so then what happens? This is just what are all the possibilities, which is interesting.
Yes.
So yeah, this is fascinating, and how would you start this? I mean, I guess it's maybe to just kind of put it, how would you put it on paper in a way where you could start solving it? That's, I guess, my question to you.
Yeah, and I think we could approach that via the similarity and difference in this question to the one before. Because the similarity is we could put out 4 spaces, similar to the digits in the last one, labeling them W, X, Y, and Z for the students. Mm-hmm. The difference, however, is that there's more of an or situation here than there was in the past one, where the Xavier-Yumeka relationship could go a couple of different ways. So we actually are probably going to need multiple sets of 4 spaces where we say, in this circumstance, we'll have this many possibilities, plus in this other circumstance, we'll have this many, plus, and we'll keep going as far as we need to cover all the possibilities.
Yeah, So where I go with this is the first thing I think is basically Zion has one of three choices. So that's like the starting point, right? So we'll say I am going to put 4 slots down again. Maybe I'll do like, let's see. So 1, 2, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. So if you've got, and we're going to put the presidents in order: Jefferson, Lincoln, Teddy, my boy Teddy, and then Washington. Then you do it again, and you have sort of like basically three little like four letter sets. So now Zion can pick Lincoln. So that's the first path. Zion can pick Theodore Roosevelt is the second path. And then Zion can pick Washington, which is the third path.
Great.
And so from there, would it be crazy to already jump to the conclusion that the answer choice has to be a multiple of 3? Or is that jumping too far too fast?
Interesting. I'd have to think through, I believe. I mean, knowing what the answer is, that sounds good.
Which I still don't.
But so there's a hint as to what one of, we're probably down to 2 answers here based on what you just said. But I'd have to think it through all the way. But I think, well, let's play it out and see.
Let's keep going. Yeah, we'll just file that one away. Also, sorry, I think I should have said the answer choices, which are 8, 9, 10, and 12. So A is 8, B is 9, C is 10, D is 12. But yeah, let's just walk through one scenario, right? So, okay, Zion, our friend, has picked Lincoln. So now, so in order for Xavier's rule to be true, Umeka has to pick before Xavier, or else it just like the whole thing breaks, right? Or
I see what you mean.
I guess it doesn't really matter, but basically, like, we'll just pretend that Umeka's picking second because it doesn't specify the draft order, and I don't think it actually matters. So Umeka picking second now has 3 options. She can pick Jefferson, except that's not possible because then the rule where Xavier comes before her in the alphabet would break.
Correct.
So it cannot be Umeka here. So then it has to be either Theodore Roosevelt or Washington.
Yep.
So if it's Theodore Roosevelt, then therefore the choice available to Xavier is only Jefferson.
Correct.
Which means that then the last person goes to Washington.
Yep.
Or if she picks Washington, then Xavier can be in one of those 2 other places.
Mm-hmm.
And then basically that means that so how many options are there? So there's 1, 2, 3 options with the first one.
Exactly right.
Yeah. So, okay.
Do you think there's anything fundamentally different about the second 2? Do you want to try another one out? How would you approach it?
I would probably try out Zion picking Washington just because it's the other extreme.
That's a good idea. I like that.
And then if it works for both extremes, then I think we can pretty safely say that it's going to work for the middle case. So Xavier picks Washington, which means that now Umeka can pick between. She can't pick Jefferson still, so she has to pick between Lincoln and Theodore Roosevelt. If she picks Lincoln, then Xavier can pick Jefferson. Let's pretend Xavier really wants to be Jefferson. That makes that rule simple. And then again, if she picks Theodore Roosevelt, then Xavier has 2 choices. So yeah, it'll be 3, 3, and 3. Okay, great.
3, 3, and 3. Very good.
Yeah, so the answer is B, 9. Yeah.
Yeah, and you always properly sort of left William to last because he's the complete wild card, the only one about whom we have no restriction. Mm-hmm. And so he's always just going to kind of fall into place. And from our point of view, logically, he's going to sort of take the last spot. Like you have to resolve the other ones first, and then he doesn't change anything. So,
yeah.
Yeah,
cool. I like the way those are super interesting problems. Yeah. I mean, so basically, like, it looks like one way, but really it's just another, almost like, how would you describe it?
Those are
yeah.
Those are called permutations when you're kind of figuring out orders.
I couldn't remember the word for a second. Yeah.
But as you pointed out earlier, it's not like a formula thing so much. It's really think it through, be ordered in your thinking, make your logic sequential, like a lot of really good logic-based skills surrounding the math aspects of it.
Yeah, exactly. And also, for the listeners, right? Like, I mean, I'm a full-grown adult and I still needed a piece of paper to figure this stuff out.
Definitely.
But once I did, it was almost fun, right?
Yeah.
I had a lot of fun solving these ones. And so, that is kind of the thing about the CLT that I think is so fascinating, right? It's not like you need to know the equation for the perimeter of a sphere, and you need to know the equation for cutting out a chunk of the sphere in order to solve the problem. And if you don't remember them, then you're kind of hosed. It's a lot more about thinking.
That's right. And the one other thing to reinforce what you're saying there with formulas is that you are provided with a formula list on the CLT, which really covers, at least from a geometry perspective, most of what you'll need to know. So that underscores that it's not as much about memorizing and more about, we'll give you these formulas. Can you apply them? Can you think logically about them? And on the harder ones, really have multi-step problem solving skills at play.
Yeah. Well, fantastic. Yeah, I think that was a really good demonstration of some cool CLT problems. Do you have anything else you wanted to add before we sign off here?
Well, just even on that last one, I'll just point back to the key moment of reasoning where you had the multiples of 3, which now that does make perfect sense as we continue to work through the problem. So I just want to point to that as a good example of even generalizing. In logic, you learn about generalizing, understanding similar elements and how they might all behave the same way. So there's so much interesting that's going on there that you can use. Hopefully that's part of your education and you can put it to use on a test like the CLT.
Yeah, exactly. Well, thank you so much. This has been Shift, a college admissions podcast for a changing world, hosted by Tyler from Achievable with Clay Daniel from Clayborne Education. You can get a free trial of Achievable's ACT and CLT courses by going to achievable.me and use the code podcast to get 10% off at checkout.